In a previous lesson, we calculated the percentiles for a given set of data, and we also learned about how to calculate the z-score given the data value, the mean, and the standard deviation. In this lesson, we are going to talk about how percentiles can relate to the normal distribution. On the screen, we can see 4 different normal distribution curves graphed. In each of these, we see the symmetric bell shape that we associate with the normal distribution curve, and we know that in each of the middle of these curves lie the mean, median, and the mode, because in a normally distributed curve, all of those are the same value. In a normally distributed curve, in the exact middle of the curve is the 50th percentile. So what that means is 50% of the data values lie below the middle of the curve, and 50% of the data values lie above the middle of the curve. If we add up those values before the middle of the curve and after the middle of the curve, we would get 100% of the data sets. So keep in mind that in a normal distribution, at the exact middle of the curve is our 50th percentile. And then based on that, we can calculate other percentiles. So for instance, we know that a little bit before the middle of the curve, we see our 25th percentile. And what this means is that 25 percentile of the data lie before this line, and then 75% of the data lie above the 25th percentile. A bit past the 50th percentile, we see the 60th percentile. So 60% of the data lies before this line, and then 40% of the data lies after the 60th percentile. Taken together, both the 60% and the 40% equal the entire amount of the data, or 100%. Now our next one, we see the 80th percentile marked, so 80% of the data lies in this green shaded region. So then how much of the data would lie in the orange shaded region? 20% would lie then in this region, 100 minus 80. So based on these descriptions, could you shade about the 10th percentile on your paper? Take a moment to pause the video and attempt this on your own. We know the 10th percentile would be well before the 50th percentile, so the exact middle is the 50%. So the 10th percentile would be somewhere early in the curve, and here we're just approximating with our shading. So around here, and then we can shade the 10th percentile would be values lower than this, and we'd find at this point in the data set, it is greater than 10% of the entire data set. Give everybody a moment. Could you shade about the 90th percentile? Pause the video at this moment and attempt this on your own. Unpause to check your work. Now we know for the 90th percentile, 90% of the data lies below this value. We know exactly in the middle of a normal curve is 50%. So to be 90% would be on this side of the middle, and pretty far out since it's greater than 90% of the data, only 10% of the data would lie above it. So we could estimate about here would be our 90th percentile. And then if we were to visualize this in the drawing, remember the percentiles all values less than this. So it would be the entire portion of the curve that lies before the 90th percentile. So our next question is related to what we've just been working on. Can you shade the portion of the curve that represents values that are greater than the 90th percentile? Pause the video now and attempt this on your own. Unpause to check your work. So while we're interested in values greater than the 90th percentile, we first need to find the 90th percentile so we can then shade values above that. From our last example, we know the 90th percentile is around here. So values that are less than our 90th percentile would be the values from the beginning of the curve up to this point. So values greater would be those to the right of our 90th percentile. So keep this in mind that for a normal distribution, we can shade certain percentiles based on our understanding of how much before or after it should be from our 50% mark. Now we're soon going to see the connection between z-scores and the percentile of a normal distribution. Let's look at the chart that connects these two ideas, and then we'll apply this in our remaining examples. Now this is the chart that relates z-scores and percentiles. Keep in mind that this chart will be provided during exams from this chapter. And the way that we would read it is we see z-scores listed in these 4 sections of the table. And then the way that we would read this is, for instance, for this z-score of 0.4, if you look to the right, you see the percentile that's listed after it. So a z-score of 0.4 corresponds to a percentile score of 65.54%. So based on the z-score for a particular data value, and remember from a previous lesson, the z-score is the data value minus the mean divided by the standard deviation. So for any data value, if we know the mean and we know the standard deviation of the distribution, if it's normally distributed, then we can find the z-score and see at that data value, a z-score of 0.4 would mean that it is greater than 65.54% of all data values. Let's see how we can apply this to some examples. Our next example says that female adult heights in North America are approximately normally distributed. And at this point, once we read that they're normally distributed, we know that our earlier chart that relates z-scores and percentiles applies in this situation. And we're told that the mean is 65 inches and the standard deviation is 3.5 inches. Now we're asked what percentage of North American women have heights that exceed 69.9 inches. Now 69.9 inches is our data value of interest. And as we solve this problem, our first step is to calculate the z-score. Now we know the formula for the z-score is the data value minus the mean divided by the standard deviation. So for this problem, that will be the data value of 69.9 minus the mean of 65 divided by the standard deviation of 3.5. Now when we calculate this, 69.6 minus 65 will give us our top of the fraction to be 4.6. Divide that by 3.5. And we see the z-score. Excuse me, I just noticed an error. Y'all probably caught it as you were working through the problem. The data value is 69.9. You notice I wrongly wrote 69.6. So that would throw off my entire answer, so I need to correct that. That's now 69.9 minus 65 would now give me a value at the top of 4.9. Now let's take the 4.9 and divide that by 3.5, and we get a z-score of 1.4. Now once we found our z-score, we use the z-score and percentiles chart that could be found in this page of the notes, and we find the corresponding correct percentile. So as you're navigating this chart, it's listed for z-scores that are negative are in this portion. Z-scores that are positive are in this portion. So as we're looking for 1.4, I see all of these scores are less than 1, so I look over to the next category. And here I see a z-score of 1.4. Let's mark that. And it has a corresponding percentile, if we read over, of 91.92. So for a z-score of 1.4, we know that's a percentile of 91.92%. So it's greater than 91.92% of all data values. So then our third step in completing problems like this will be to draw our normal curve, and we know it always looks like this bell shape. I've marked the middle value where I know 50% of the data lies before, 50% lies after, and then locate the percentile. So our percentile was 91.92. Now we know something that's in the 91.92 percentile, most of the data values would lie below, So we're looking for somewhere around here. And we know about 91.92% of the data lie in this green shaded section. Now for our value of 69.9, notice we were asked to exceed that. So we don't want values less than that, which would be what's pictured in green. Instead, we want the section to the right. So if you're asked to exceed, you're looking at the values to the right of your percentile. And we're curious about what percentage exceed that. So in this case, we know the entire curve is 100% minus the green curve, which we don't want because we want to be greater. So 100% minus 91.92% would give us 8.08% is what's shaded as the values that lie above the 91.92 percentile. And this step represents the final step, step 4, which is based on the wording of the problem, whether we want to be greater or less than that percentile, identify which portion of the bell curve we're interested in, and then calculate our final answer. So as we wanted to exceed the value, at this point we were exactly at the value, so to exceed would be to shade to the right. We know the entire percent is 100% minus the portion we don't want, which is this green percentage, leaves us with those values that are above that data set are 8.08%. So keep in mind these 4 steps as we complete the remaining problems that relate the z-score and the percentile for a normal distributed data set. Now in this example, we are told that the distribution for the life of refrigerators is approximately a normal distribution. Remember, once we're told it's a normal distribution, we can apply this chart. We know the mean is 14 years. Standard deviation for this problem is 2.5 years. And then based on that, we're asked which percentage of the refrigerators that we're looking at would have lives between 11 and 18 years. Now, one thing to note in this problem is since we're given 2 data values, we need to calculate 2 different z-scores. For the data value x equals 11, we'll calculate the z-score, keeping in mind the formula data value minus mean divided by standard deviation. And then again for the data value 18, we'll calculate the z-score using the formula data value minus mean is standard deviation. Let's do the first one together, and then I'll let you attempt the next one on your own. We know our data value for the first one is 11 minus a mean of 14 divided by a standard deviation of 2.5. 11 minus 14 is negative 3 divided by 2.5. And we get a z-score of negative 1.2. Now if you would, take a moment and pause the video, attempt finding the z-score for the data value 18 on your own. So for the data value 18, it's 18 minus the mean of 14 divided by the standard deviation of 2.5. That gives us 4 divided by 2.5. Typing this into our calculator, and we get a z-score of 1.6. So we've done step 1 for both. Now that we have the 2 z-scores, we need to find these in our percentile chart. Let me zoom in here briefly. Now, our z-scores of note were negative 1.2. We know the negative z-scores are on the left portion of the chart, so negative 1.2 is here. So we see for a z-score of negative 1.2, that's a percentile of 11.51. Our z-score that corresponded to 18 was 1.6. We know that would be in the right portion of the chart. Find the z-score of 1.6 and locate that in your mind's eye. We see for a z-score of 1.6, the percentile is 94.52. So let's write that down under step 2 for both of these. Okay. Now that we have the percentiles, we will draw this on our normal curve. Now remember, as you're drawing this into the normal curve, you keep in mind that the exact middle is the 50th percentile. Values to the left are values lower than the 50th percentile. Values to the right are values higher. So about the 11.51 percentile should be very far to the left, maybe about here. And then the 94th percentile should be even farther to the right because it's very close to 100% or all the data. And we can estimate that to be about here. Now keep in mind what this percentile means. It means that 11.51% of the data lie below this value. So 11.51% of the refrigerators last less than 11 years. Now a z-score of 1.6 going to the 94th percentile means that 94.52% of all the refrigerators last less than 18 years. And then the portion of refrigerators that would last greater than 18 years is this very small portion of the curve that lies above the 94.52 percentile. Now that we've listed our percentiles on the curve, we have something to focus on. We need to go back to how the problem was worded. That's our step 4. So based on the wording of the problem, shade the correct percentile that we're looking for, and then calculate your answer. So as we're looking for values between 11 and 18, well, 11 corresponds to a z-score of negative 1.2, which is a percentile score of 11.51. 18 is a z-score of 1.6, which is a percentile of 94.52. So to be between these two things would be this portion of the graph. Now keep in mind what percentiles tell us. The 94.52 percentile is an overestimate. It's all the values to the left of 94.52. The 11.51 percentile are the values to the left of it. Neither of these directly is what we're looking for. Instead, we want the portion in between these two values, which I have here now shaded in blue. So remember, whenever you're asked to find between, what you can do is you can take the overestimate, take the entire 94.52 percentile, that's a little bit too much, and then subtract off the portion that we don't want. And in this particular problem, the portion we don't want is that which is found by the 11.51 percentile. So we always do larger percentile minus smaller percentile, so 94.52 minus 11.51% will be equal to 83.01%. So for problems where you're asked to find the percentage between, find the percentile for the higher value, the percentile for the lower value, and then subtract them. In this next example, we are told that in one area, the distribution of monthly miles driven by motorists has a mean value of 1,200 miles and a standard deviation of 150 miles. Now we're told to assume that the number of miles is closely approximated by a normal curve. Now keep in mind, once we're told that the data can be approximated by a normal curve, we have a lot of information then regarding the z-score and their corresponding percentiles. So we're asked to find the percent of all motorists which drive the following distances: less than 1,200 per month, greater than 1,200 per month, between 1,200 and 1,600 miles per month. Let's deal with these one at a time. We know in each of these problems the basic structure is to calculate the z-score, or z-scores if there's two data values mentioned. Using the z-score and percentiles chart listed earlier in this note packet, find the correct percentile. Draw the corresponding normal curve and locate the percentile on the curve. And then based on the wording of the problem, find the correct percentage and calculate your answer. Let's go through these first 4 steps for the first problem. Now we know our z-score is always the data value minus the mean divided by the standard deviation. So for us, our data value is 1,200 minus the mean of 1,200 divided by the standard deviation of 150. 1,200 minus 1,200 will give us 0. Any non-zero number, 0 divided by any non-zero number is 0. And now for step 2, we'll need to look at our z-score and percentiles chart. For the z-score and percentiles chart, we see given a z-score of 0, the corresponding percentile is 50%, so that's exactly in the middle of the normally distributed curve. So z equals 0 corresponds to a percentile 50th. Next, in our normal curve, we know exactly in the middle is the 50th percentile. So for values less than the data value of 1,200, 50% of them lie below this portion. Now, based on the wording of the problem, since we want less than 1,200 per month, we care about the values before the 50th percentile. So 50% of all data values are less than 1,200 miles per month. Next, we look at values greater than 1,200 per month. Now, since the value of 1,200 is a z-score of 0, which is the 50th percentile, we know to be greater, we would just be to the right, and at the 50th percentile, half lies below, half lies above. So 50% of the data values are above 1,200 per month. Now, as we finish up to our third part of the problem, it says between 1,200 and 1,600. Now, we know for 1,200, the z-score is 0, which is in the 50th percentile. So all we need to do is calculate the z-score for 1,600, find its percentile based on our chart, and then draw the correct distribution, and based on the wording of the problem, figure out what we need to go do from there. So for 1,600, remember, z-score is always going to be the data value of 1,600 minus the mean for the data set, which for us was 1,200, divided by the standard deviation for the data set, which here is 150. Now that will be 400 divided by 150. And we type this into the calculator, we get 2.666 repeating. Now let's look at our z-chart and percentile chart to understand how we should round this and reason based on this. As we look at the z-score values in the table, we see that all of them are rounded to about 1 or 2 decimal places based on the location. So for instance, for values close to 2.66, as we look close to here, we see there to 1 decimal place. So to make this fit into our chart, let's round this to 1 decimal place. So rounding 2.666 repeating, that would give us a rounded value of 2.7 as the values after the 6 or 5 or greater. Now 2.7 in our z-chart corresponds to a percentile of 99.65. Remember, if you need to see this chart closer, it is on the first page of this section of notes in our note packet. So we know that for values that are 1,200, that corresponds to a z-score of 0, which is our 50th percentile. And then for values that are 1,600, that is a z-score of 2.7, which is in the percentile of 99.65. Drawing this on the graph would be somewhere at the very tail end of the curve, since it is greater than almost all the data values. And now we do step 4. Based on the phrasing of the problem, we think about what portion we're interested in. As it said between the two values, we know when it's a between question, you take the larger percentile and you subtract from the smaller percentile we found. So we will have 99.65 minus the 50th percentile, and we'll get that 49.65% of all the data values lie in between 1,200 and 1,600 miles driven. Now in this next example, we've seen this type of problem completed a few times so far, so I would encourage you to pause the video and attempt this problem on your own. Whenever you finish the problem, unpause to check your work. So as we read through this problem, we are told that systolic blood pressure readings are normally distributed. That tells us we can use the z-score and percentiles chart. We know that the mean is 121, standard deviation of 15. And then based on this, we're asked what percentage, so the idea of percentage is telling us that we're looking for the percentile, of blood pressure readings are below 130. So our data value is 130. And then once we get to step 4, we'll pay attention to the phrase of below. So for now, let's calculate the z-score. We know the formula is data value minus mean divided by standard deviation. So in this problem, our data value is 130 minus a mean of 121 divided by a standard deviation of 15. Now, 130 minus 121 is 9. Divide that by 15, and if we type that into our calculator, we get a z-score of 0.6. We look in our chart for where 0.6 is as a z-score, and we see it corresponds to the 72.57 percentile. So a z-score of 0.6 is a percentile 72.57. Now step 3, we need to draw a normal curve and locate this percentile. Now we know in the 72.57 at exactly the middle is the 50th percentile, so 72's a little bit to the right of that. About here's our approximation of where the 72.57 percentile is. We know that to the left of that are all the values less than this corresponding z-score. To the right are the values greater than. So now for step 4, we go back to see how the problem is phrased. As we cared about readings below 130, at this point is the value for 130, which has been changed to the z-score of 0.6. So to be below is to the left. And it asks how many percent are less than that? Well, we know all the values to the left comprise of 72.57% of all data values. Now, as a quick extension to this problem, can you think how you could find the percentage of blood pressure scores above 130? Keep in mind that as we completed the problem above, it was for below 130, so we've done most of the work, you just have to reason a little bit different based on the work displayed on the screen. What would give you the values above 130? Well, if our percentile here corresponds to a data value of 130 with its corresponding z-score of 0.6, then the values above are those to the right, so that would be the portion of the curve shaded here in orange. Now we know the entire curve, green plus orange, is 100%. So in order to find what we see in orange, we need to take the entire value and then subtract off the portion that we do not want. And in this case, the portion we do not want constitutes the 72.57 percentile. So in order to find the values above the data value of 130, we would take the 100%, which is the entire bell curve, subtract out the green portion, which is 72.57%, and then what we were left with is the orange portion, which when we type into our calculator is 27.43%. So all there is to these type of problems is to understand when they say that something can be normally distributed, that means that we can use the information gathered in this chart, assuming we can first calculate the z-score, then based on the chart, find the correct percentile, then draw the normal curve and then look at the percentile where it would be located, and finally, based on the wording of the problem, find the correct shading portion of the normal graph we're interested in, and then find that related percentage. We know that to be below is the left of the point in the normal curve, above is to the right, and then for between problems, you have to calculate both z-scores and percentiles separately, and then take the largest minus the smallest. So as always, if you have questions, reach out to me via our course email, and I'll be happy to answer them.